Namaskar friends, welcome to session 14 in our course on operations management. We are currently in the third week of our discussion, and in this course we have weekly discussion on specific topics. In week 1 we discussed the basics and fundamentals of operations management. In week 2 our complete focus was on product design and development, and in week 3 our focus is on forecasting. We want to find out that how much quantity we should produce in order to be successful and competitive in the market, and in that direction we are trying to find out the numbers. Actually, we are trying to find out the demand that is being created in the market. We are trying to figure out the sales expected in the market, and how we can find out. If you remember, just to have a brief overview of what we have covered till today in our discussion on forecasting. If you remember, in first session we discussed the need requirement of forecasting. We have seen how forecasting can help us, or how forecasted values can help us in making various decisions, such as the manpower planning, the materials planning, the planning of the various activities, the time schedule of the various activities. All that depends upon the forecast, that what actually we are going to produce in a specific period of future time, or in a specific period of time in future. We have seen the basics of forecasting. Then how to do forecasting. In the second session we discussed the forecasting system, in which we discussed, or in which we have seen that what are the various elements of the forecasting system. We have seen that there are inputs, there is a forecasting method, and there is a output. Then we have seen this system operates under certain constraints. Constraints can be in terms of time, constraints can be in terms of data that is available, constraint can be in terms of money that is available to carry this exercise, constraint can be in terms of skill that is required to make a forecast. So there are constraints under which this overall system, or under which we have to operate to use these inputs using a method to make a forecast. And then apart from the constraints, there are certain decisions that we have to take. And what are these decisions? We have to take a decision that which method is applicable for a specific set of problem, which data is relevant for making a forecast. So two things, the method and the data we have to select. So that we have covered in the forecasting system. Then the next stage we have covered the qualitative methods of forecasting, in which we have seen the estimate or the survey technique, and we have seen the Delphi method of forecasting, and we have seen that what are the advantages of qualitative methods. If you remember, we have seen that they require less time for making or developing a forecast, the money required is less, the skill set required is less. So basically most of the constraints are taken care of by the qualitative methods of forecasting, especially the survey technique and the Delphi method. But still these methods are applicable. If you remember, we have seen they are applicable where we do not have any previous data available with us, the historical data is absent, or we are coming up with a completely new product and there is no comparative data, no historical data available with us. We are doing a long term strategic planning. We are not relying on the existing data. We want to forecast 10 years from here on. So there also our qualitative methods are good. But suppose our product is not new, it is an old product, and we have maybe last 15-20 years data available with us. To be more specific, last 5 years data available with us, data related to the demand of the product, the actual sales of the product in the last 5 years. So that data is available with us. So once such information is available with us, we can definitely make use of this information for developing a forecast. And how this information we are going to use, that we will see today. So we have seen three things till now: the need, requirement and the importance of forecasting. We have seen the forecasting system, we have seen the qualitative methods of forecasting, that is survey technique and the Delphi method, and today we are going to cover the simplest of the quantitative methods of forecasting. These are simple methods, do not require much skill and are definitely applicable when we have the previous year's sales data available with us. So let us now start the discussion related to the quantitative methods of forecasting. So again, coming back to the classification, we have qualitative methods of forecasting and we have quantitative methods of forecasting. The qualitative methods we have covered in the last class. Today our session will focus on quantitative methods, and in quantitative methods we have average, moving average, exponential smoothing, and we can also have causal methods like linear regression and multiple regression. So we will try to cover all these methods in our sessions that are left in the week on forecasting. As I have already told, we are focusing on various topics on weekly basis. First week was basics of operations management, week 2 was product design and development, week 3 we are focusing on forecasting. Today is the 4th session, and in the 5th session we will wind up our discussion on forecasting. So let us now see the simplest methods of making forecast using the previous year's data that is available to most of the companies. So this is something, or this method is something which is applied where we have the same product, it may not be a new product, and we have the previous data available with us. Now the data for previous years may vary in a different pattern. So let us see what are the variations. The topmost, this is a trend. We see a trend component. This is an increasing trend component. So on x-axis we have time and on y-axis we have the demand data. So we see a continuously increasing trend in the demand over the last few years. Similarly, contrary to that, we see a trend which is decreasing in nature. So with time the demand is decreasing over the last 5 to 10 years. Similarly, we can see that there are seasonal variations. This type of plots we have seen in our session 1 or 2, I do not exactly remember, where we have seen the variation of demand data with time. So there also we have seen the seasonal variation. Then there is a business cycle variation, in which we see that there is a increasing demand and then it is decreasing. So this is a business cycle. Maybe many times we correlate it with the economic boom or the economic depression. So maybe that cycle may continue for 5 to 10 years time. So for 5 years we have maybe economic boom, so the demand will be high, but maybe after 5 years there can be depression, so the demand comes down. So basically this is the variation of the demand in the previous years. Now based on this we have to make a decision that what can be or what will be the forecast for the next year. On your screen, if we see the first graph, to take as an example, the demand is continuously increasing. So we can expect that the demand will be higher in the next year. So for last 5 years, if we have an increasing trend, we can expect that the next year or the 6th or 7th year forecast must be higher than the demand of the 5th year. So we are already focusing on the last 5 years data and trying to forecast for the 6th and the 7th year. Since the trend is increasing or there is an increasing trend in the demand data, we forecast that yes, next year the demand will further increase. So we make use of this data in a judicious manner for making a forecast. Similarly, if there is seasonal variation, we can take into account the seasonal variation and include it in our time series model and calculate the seasonal indices and make a forecast on season to season basis. Usually we do it on quarter to quarter basis. So the whole year is divided into 4 quarters and the forecast is made on quarterly basis in case of seasonal variations. Similarly, there can be random or erratic behavior of the data, and whenever there is random or erratic behavior of the data, we can use a simple average method for making a forecast. So we can average out the readings and use that averaged value as the forecast. So this is the variation of the data. Why this slide is put here? Because now we are going to see the methods that make use of this data. So first of all, we have to see that what is the variation in the data. Suppose we see a trend, we should select our method accordingly. There is no trend, there is random variation of data, so we will say okay, a normal average or a simple average can give us the forecast for the next year. So looking at the data, we have to take a decision that which particular method we have to apply. So everything is interrelated. If we have seen in forecasting system that there is an input, there are a combination of forecasting methods and which produce a forecast. And what decision we have to take? We have to take a decision that which method we are going to use. And here also, looking at the distribution, looking at the variation in the data over the period of time, we try to select the best possible method for making a forecast. And we will try to see some of the simple methods of making a forecast for the next year. Now again, this is just the classifications based on qualitative and quantitative, and in quantitative models which are we see as more formal, because in case of qualitative we say survey technique which can be slightly subjective also, but here the things will be more objective, more formal in nature. So we usually use time series models or causal methods of forecasting. For example, regression, we can develop a curve fitting equation and make use of that curve fitting equation for making a forecast. Now let us see a simple moving average method. Simple average is clear to everybody. So here we can see it is simple average only. So here we are taking last maybe n data points and we are adding all these data points and dividing it by n. So this we can say is a simple average method. So moving I will explain maybe slightly later, but here we can just conclude that this is simple average of the data only. If you see that we are adding from dt plus dt minus 1 plus dt plus 1 minus n. So basically we are focusing on the last 5 years or 7 years data, adding all the demand data for the last 7 years and dividing it by the number of years for which we have added the data, dividing it by 7 for the last 7 years, divide it by 7, so we get an average value, which is a simple average method. So where forecast ft we can say, or ft plus 1 is average of n previous observations or actuals or dt. So dt is the demand data for t period. So we add all these data points and divide it by the number of years and we get the simple average method. Now why simple moving average is required? The previous one, it is written simple moving average, but it is actually simple average, and here we have simple moving average. Now why simple moving average is important? Now let us see data that we have with us. Again on x-axis we have time, which can be in terms of year, and on y-axis we have suppose the demand data that is available with us. I am plotting maybe last 5 years data, and this is the trend on your screen. So now if you see, we use a simple average method of making a forecast. What will be the average? It will be somewhere around this point. So whether it is a correct forecast, we see if we consider the last 3 data points only, what will be the average? The average will be somewhere here. So considering the last 5 years data, this is my average, and considering the last 3 years data, this is my average. So from this graph we say that, for example, let us see, this is the actual demand for this year. This is the demand or forecast. Actual demand, we should not say, this is actual demand. Actual demand for the year, maybe this we can say 2018. So actual demand is also available with us. So if we see the error, actual, this was the demand, the error for average method for 3 years is this, and if we calculate the average based on all the 5 years, this is the error. So we can very easily see that the error by using the last year's data or last 3 years data is less as compared to the last, by considering the last 5 years data. Why we should focus on the trend? In the previous slide, if you remember, we have seen that there are different data trends. There can be an increasing trend, there can be a decreasing trend, there can be a random variation, there can be a business cycle, there can be a seasonal variation. So as a forecast engineer or engineer who is going to make a forecast, we must focus on the variation of this data. Try to understand the data so that we are able to make a good forecast. Now here, if as a normal engineer I use all the 5 data points for making a forecast, my forecast will definitely be lower than the actual demand data, and I will be under forecasting. But if we slightly change our method, we only focus on the last 3 years data, I am slightly closer to the actual demand. So that is basically the meaning of the simple moving average method, that if 5 years data is available with us, we may not like to focus on all the previous 5 years. We will only like to focus on the most recent demand that is available with us, or the demand data that is available with us, because that is going to give us a more accurate, a more reasonable idea of the forecast for the next year. So this type of method where we consider maybe 1, 2, 3, last 3 years data only, we call this as a 3 period moving average method or 3 period moving average. Again, maybe when 2018 forecast we have done, actual demand data is available, we use the 3 period moving average. This was my forecast, this was the actual demand data. Now maybe for next year, when I have to do the calculation for 2019, I will delete this data or this data point, and I will focus on, this will become 1, this will become 2, and this will become 3. The actual demand for 2000. This is the actual demand, this is the demand data for 2017, this is the demand data for 2016. So again I am considering 3 data points only for making a forecast for the year 2019. So I am considering 3 years data only for doing my average calculations. I am not considering the last 10 years or 15 years or 20 years data. But some of you may be wondering that where simple average can be used. Now in similar graph, if my data is varying like this, I have drawn large number of data points. So now in case 2, I am considering these data points only which are encircled. So you see, this is my data 1, 2, 3, 4, 5, 6, 7, and suppose this is 8. So I have 8 data points now. There is no trend I can observe. So if I plot them, so there is no trend. So in such cases, if this type of data is available with us, we can calculate the average and we can make a forecast. So when there is random variation and there is not much variation, suppose the random is varying to a large extent. In 1 year we have very less sales, next year we have very large sales. So if the variation is large, we have to look that which method we should follow. But if the variation is not that much, the value is just scattered around a central line, so we say that yes, there is not much variation, let us follow the simple average method only. So when such type of random variation is observed in the data, we can very easily use a simple average method for making a forecast. And if there is a trend, like in the previous data there was an increasing trend, in those cases we must follow a moving average method, giving more weightage to the previous year's data, that is just maybe close to the year for which we are forecasting. Suppose we want to make a forecast for 2018, we should give more weightage to 2017, 16, 15 and exclude all the other data points when we see that there is a increasing or there is a decreasing trend, and this is called the moving average method. But we are considering last 3 years data only and giving equal weightage to all the 3 years. But in many cases it may so happen that we are seeing that there is an increasing trend. So I will try to just further do my calculation that I give more weightage to the last year's data, slightly maybe less weightage to the previous year data, and even smaller weightage to the previous year data. So when maximum weightage is given to the last year's data, smaller weightage to the further data, even smaller weightage to the farthest data point, if I am considering 3 data points only, then we call this method as the weighted moving average. So moving average is giving equal weightage to 3 years data. Must I also tell you that it is not 3 years data only. We can have 4 period moving average, we can have 5 period moving average, we can have 2 period moving average. So that is the decision that lies with the engineer, that how he is going to select his period. So it can be 3, 4, whatever data the observer feels or the engineer feels is good for making a forecast. So suppose in my example we have taken that 3 period moving average. So when I give equal weightage to all the 3 periods, I say it simple moving average method in which no weightage is assigned to the previous years. But if I assign weights also, that more weight is assigned to the 2017 data, less weight is assigned to 2016 data, even lesser weight is assigned to 2015 data, then that method we call as the weighted moving average method. So this is the basics about the averaging methods for making the forecast. So 3 I have tried to explain. The first one was the simple moving average, in which all data are included, they are given equal weightage and we do the calculation, as is this example. So we see there is a random variation in the data, so we use the simple average method only. So we calculate this plus this plus this, addition of all these data points and dividing it by 1, 2, 3, 4, 5, 6, 7, 8. So we get a simple average technique for making a forecast. Then we have seen a moving average. When we see there is an increasing trend, we consider the last 3 data points only, and for the next year we consider the previous 3 data points only. That is simple moving average method. That can be 3 period moving average, 4 period moving average, 5 period moving average. And finally we have seen that if we assign weights to the previous years, we are using a method that is called the weighted moving average method by assigning maximum weight to the last year's data, slightly less weight to the last year data, and even lesser weight to the last year's data, maybe 2 years previous data or the 3 years previous data. So these three methods fall under the averaging methods for making forecast. And let us now quickly see the presentation and try to revise what we have covered on the board. So simple moving average, we will try to understand now. Note that the n past observations are equally weighed. So in case of simple average, all observations are given equal weight. Issues with the moving average forecast are all past observations are treated equally. Observations older than n are not included at all. Requires that n past observation be retained. Problem when thousands of items are being forecast. So simple average has got its own limitations. Now in simple moving average, what we try to do, we try to include the n most recent observations only. As in our example you see, we were using only last 3 years observations, last 3 years data for making a forecast. So in simple moving average, previous to this we have only covered simple average method. Now simple moving average, wherever the word moving is coming, we will define that our calculations are for 3 period moving average, we are considering the last 3 observations. 4 period moving average, we are considering the last 4 observations only. Please don't get confused. I think in the title it was written simple moving average, so it was simple average only. So moving you can just eliminate from there. So in moving average, we will it will include n most recent observation. N is the number. So if n is 3, we will call it n is equal to 3, that is 3 period moving average. If n is equal to 4, we will call it as 4 period moving average. So n is a, you can say, variable. So they are weighed equally. So in our example we have given equal weights to all the 3 periods that are previous to the year of forecast, and we ignore the older observations. So in our example we had 5 observations. By calculating a simple average, we were not getting the actual forecast. We are seeing that there is a lot of variation. It is digressing from what is expected, what can be we can estimate it. So we thought, let us give last 3 observations equal weight and try to do the calculation. So last 3 observations were only considered, and the average was calculated for last 3 observations only. So as per my slide, ignore the older observations. So we have ignored the 2 observations. These 2 were ignored and only these 3 were considered. But we have given equal weightage to the calculation. We have calculated for these 3 values only, and we have given equal weightage. This plus this divided by 3, we are getting this average value. So simple moving average, 3 periods considered, equal weight given to each of the 3 years. But that also we see is digressing, or there is a forecast error. So how we can overcome this? When equal weightage is given, there is a problem. Still we are far away from the actual demand value. So this is just an example. Let us consider a simple average examples only, and then we will go to the weighted moving average. XYZ television supplier found a demand of 200 sets in July, 225 sets in August and 245 sets in September. So your demand data is now given to you, because examples help us to understand the theory in a better manner. So let us take this example. So the 3 previous months data is on your screen. 200 sets for July, 225 sets for August and 245 sets in September. So a supplier found a demand. So this demand is already known to us. Find the demand forecast for the month of October using simple average. So what we will do? We will give equal weightage to all the 3 years. So 200 plus 225 plus 245. Equal weightage means divide it by 3. So that is a simple average method of forecasting. So the simple average you can see, you add the 3 and divide it by 3, so you can calculate the simple average method. Now simple moving average method, now see the XYZ refrigerator supplier has experienced the following demand for refrigerators during the last 5 months. So 20, 30, 40, 60 and 45. Can you see a trend here? You can see, observe the trend. 20, then it increased to 30 in March, then 40 in April, 60 in May, and finally there is a decrease of 15 refrigerators in the month of June. But still there is an increasing trend that we can observe. So if we use simple average method, what will we do? There are 5 months data available with us, so we will add all these 5 data points, 20 plus 30 plus 40 plus 60 plus 45 divided by 5, and we will get our forecast for the month of July. But in simple moving average, we will try to give more weightage to the previous last 3 or 4 years or 3 or 4 months data only. This problem is related to months, so we are taking months as our time domain. In that problem we have taken yearly data, so we were considering year on our x-axis or on the time scale. So here we can see, if we do simple average, we will be getting a value somewhere near, let us see if we have solved that. Find out the demand forecast for the month of July using 5 period moving average and 3 period moving average using simple moving average method. So we will see 5 period moving average in our case will become simple average only. 1, 2, 3, 4, 5. So we have 5 months data. We are considering giving equal weightage to all 5 months. So we will add up everything and divide it by 5. So let us see. So by 5 period moving average, considering all 5 months or giving equal weightage to all 5 months, we get the forecast as 39 units. Whereas for 3 period moving average, if we see giving n equal to 3, we get 48.33, that is 49 units. So you can see the difference between the two forecasts. One forecast is giving 39 units or 39 refrigerators, another is giving 49. So basically if we give more weightage to the previous year's data or previous month's data, it will be more realistic and it will give us a better forecast as compared to giving equal weightage to all the data that is available to us. Why? Because when we looked at the trend, we could see an increasing trend in the data, and from there we could see that we must not give equal weightage to all the 5 data points. We should give more weightage to the last 3 data points. So this, I think by now you have understood a difference between the simple average and the moving average. Suppose now we want to forecast for the month of August. So we will make use of the data points of July, June and May. So May, June and July data we will consider for making a forecast for August. Now we want to make a forecast for September. We will use the actual demand data for August, July and June. So we will keep on, the average will keep on moving because we are giving more weightage to the previous 3 years or previous 3 months data only. Now let us see the last example for today. I have explained this with the help of an example there. We have given capital W weightage to the last year's data, then we have reduced the weightage for the last 2 years. So we will see that with the help of an example. Let us take this problem. The manager of a restaurant wants to make a decision on inventory and overall cost. He wants to forecast demand for some of the items based on weighted moving average method. Please note, weighted moving average method. For the past 3 months, he experienced a demand for pizzas as follows. Now if we look at this data that is on your screen, the demand for pizzas in October is 400, November 480 and December 550. Now there is an increasing trend in this data, so we wish to give more weightage to the demand of December and slightly lesser weightage to the previous 2 months, that is the months of November and October. Now let us try to see. and solution of this problem. So we want to find the demand for the month of January by assuming suitable weights to the demand data. So we will give weights to the data of the previous 3 months. The months available or the data available with us is for the months of December, November and October. So we will looking at the data, we will like to give more weightage to the month of December, slightly less weightage to the month of November and slightly less weightage to the data for the month of October. So we will calculate the weighted moving average by the summation of a multiplication, that is the CI into DI. So CI we say that is a weight that is assigned to that particular month, and DI is the actual demand for recorded for that particular month. So CI is the weights for the periods and DI is the demand for the period. So let us see, CI is 0.25, the weight for the next month is 0.3 and for the latest month is 0.5. So ideally this should come equal to 1, but okay, this C1 maybe we can take 0.20, but this is just to explain the idea that how the calculation can be done. Now we will see C1 is multiplied with D1 and D1 you can see is October. So we are giving less weight, very less weight, maybe only 20%, maybe 0.2 only to the October data. So we can see 0.2, so 0.2 being multiplied with 400 and the next data is 480, this we are multiplying by 0.3 and the latest data if you see is 550, it is given maximum weightage, so we are multiplying it by 0.5 and once we add these three values we will get our forecast. So here if we take it as 0.2 we will get this value of 100 as 80 and the total value will be 499 units. So the forecast is 499 and for your exercise you can do a forecasting using simple average by adding these three values 400 plus 480 plus 550 divided by 3 and certainly you will find a difference in the forecast as we have forecasted using the weighted moving average. We have given 0.5 weightage to 550, 0.3 weightage to 480 and 0.2 weightage to 400. So we have reduced the weightage over a period of time. We have given maximum weightage to the latest data of December, we have given slightly less weightage to the data of November and you get least weightage to the data of October. Similarly we can use this method of giving the weights, combining it with the moving average also. In our previous case we had 3 data points only, we assigned weights to all the 3 data points and did the calculation and made the forecast. Whereas in case of if we have a large, maybe last 12 months data is available with us, last 24 months data is available with us, we wish to exclude some of the data points, we will focus only on the recent data points and we will get a more accurate forecast. So here on your screen you can see the past data on the load on the lathe machine is shown below. So we have a data starting from June, July, August, September, October, November. So we have 6 months data now available with us, and if you can see 585, 610, 675, 750, 860, 970, there is an increasing trend. And if we use a simple average method for forecasting, add all these values and divide it by 6, we will be under forecasting. We can very easily look at the data and it is not going to give us the right answer or the right forecast. So what we need to do, we can focus on the last 3 years, last 3 months or the last 4 months data. So if we take the last 3 months data also, there also we see lot of variation. For last 3 months you see 750, 860 and 970. So here what we can do, we can assign more weightage to 970, slightly less weightage to 860 and even less weightage to 750. So we are combining now two things, we are using a moving average and we are assigning weights also to the previous year's data. or previous month's data, and it will give us a fairly accurate forecast based on the information and the data that is available with us. So this is a solution. What is the problem for which we are solving? We want to compute a weighted 3 months moving average for December, where the weights are 0.5 for the latest month, 0.3 and 0.2 for the other months respectively. So the weights we are assigning same, and we want to compute for the month of December, that is the forecast for the month of December. So here you can see we have September, October, November data already available with us. So 3 periods only we have to consider, and then we assign weights are also given: November 0.5, October 0.3 and September 0.2. Using the same approach, we can very easily do the calculation. A 3-month weighted moving average forecast for December is given by weightage of November, that is 0.5, multiplied by the demand for November 970, plus weightage for October multiplied by the demand for October, plus the weightage for September multiplied by the demand for September. Add the 3 values, we will get our forecast. So with this we close today's session. I think it has been a very busy session. We have tried to see the simple average method where we can apply. It is still on the screen, where there is a random variation in the data and the variation is also not that large. So if the data points are scattered around the central line, we can make use of simple average method. We have seen moving average method and we have seen weighted moving average method. We have tried to see simple examples which help us to solve problems related to simple average, moving average, weighted moving average method. In our next session, we will further try to reinforce our knowledge and information related to quantitative methods of forecasting. Thank you.